Right, so first of all, I'm not using my microphone anymore, like my microphone, because my camera microphone seems to be pretty decent at picking up my voice. Um, I mean, I complicate it in anyway because I don't have a thing, like a plug for my thing. But even then, like even if I did have another USB slot, like the microphone just takes up so much space on my on my thing, on my desk, and I can't really have my keyboard and my thing on the same desk, at least right now. Like really, I need like one of these microphones that comes like next to you. So yeah, so I don't know. For now, this will do, I guess. By the way, I've been thinking a lot, or well, maybe not a lot, but like I did like a deep think session, for my language, my programming language, about types, and how I want types to work, and I really want to like when I'm saying true, right? It's called true for a reason. It wants to be the true programming language, the one that is like truly the programming language, which means it needs to age well. And for it to age well, the type system needs to be atomic. It needs to be a language that will survive on binary system with bits, on ternary system with trits, that is what they're called for those who don't know, on quantum computers with qubits. I want this language to truly survive convention and like just be the truest language it can be, like in terms of what you want a language to be. And what I want a language to be for starters is to have a really flexible type system. So for example, a uint 8, right? A uint 8, right? An unsigned integer of 8 bits. An unsigned integer of 8 bits, yeah. Or an 8-bit unsigned integer, let's say. If you were to represent that in a true type system, because for most languages it's just a built-in type, right? That's like inherent to the computer. But if you want to have it be a truly atomic type, a uint 8 is made of 8 bits, right? And those bits can be interpreted as one value. So that's what I need to model in my language's type system. It should be a product type of 8 bits, where a bit is the atomic unit of that system. Okay? So now, for those who don't know, a product type, you have product types and subtypes. Subtypes are also called co-products, because like co-products means the opposite of product, whatever. And a product type is think of it as like a group of types together. So like a struct in C or Rust, or a class in Java would be a product type, because it is a single type that consists of subtypes, right? Think of it that way. Like a person could be a product type of name, address, age, and so on. Meanwhile, a subtype or a co-product type is like an or, right? So think of product as and. It's this and this and this. A subtype is or this or this or this, like an enum, right? An enum is like for example in Rust, the result, or actually better, the option enum is either some or none, right? It's an enum, or a tagged union in that case. But a tagged union is still also a sum type. It's just a sum type of product types, because like with a Rust result type, for instance, you have OK and error, right? But the OK and error both contain data as well. So you can mix them. So like that's there's the introduction to sum of product types if you didn't know. I mean, it's pretty straightforward. So naturally, if I have 8 bits representing a value, 8 bits come together to represent one unified type, then that is literally a product type. It's 8 bits. It's 1, 2, 3, 4, 5, 6, 7, 8 bits that form a product type. Likewise, a uint 64 would be 64 bits, right? So it'd be a product type of 64 bits. And then the next step is to have a system for having the programmer specify how that type can be interpreted as one value. For example, let's say in Java, right? I can have a person class with their name, their address, and whatever, right? And then I can print that person object. And what will happen is I believe I do have to write a custom formatter, or maybe I don't know. But I can write a custom formatter for how it is printed. And that string that is printed is almost like the value of that class. Now, in this case, it's a string value, but like that's essentially how it works, right? Or an even simpler example, a uint8 is literally 8 bits being interpreted as a value. Like that's literally what happens on your system. It's just that for most programming languages, that is kind of built into the language, or like built into not even the language, built into the compiler. Whereas for my language, I want to have that be explicit. So that like I can do, person plus 5 might equal a value, because I can have person evaluated to an integer value, the same way I can have it evaluated to a string value. Now, some types may not have integer values, and that's fine, and that will be defined through conversions. So basically, you can convert if there exists a mapping. If there doesn't exist a mapping, you cannot convert, like that. So that's what I'm kind of cooking up right now. Anyway, so I want you to talk about that as a preface. A preface to watching this video, if I can just switch my screen here, called the Unreasonable Effectiveness of Constructive Data Modeling. Now, I don't really know what this talk is even about, but the thumbnail looks to be about types, and it says constructive data modeling, and when I think constructive, I think of like things building up to bigger things. And then here in the thumbnail, we see like a bit of like set, like a Venn diagram of sorts. So I'm very curious about what that is, what this talk talks about. But wait, what I'm describing is not like it's probably not a new idea, but it doesn't exist in a mainstream language yet. So I'm curious about that. Oh, also, to further elaborate, first of all, I said that this system would transcend whether you have a bit system or a trit system or a qubit system, right? Because the only thing that is built into the model language, the compiler, would be the atomic unit. So for a computer, that we're used to, it'd be bits. The bit would be intrinsically designed in the compiler, and so you do not define it, it is compiler defined. But then if I'm on a ternary system, then the trit, right, which is the atomic unit of ternary, would be the atomic unit. And that would be compiler defined. And then the bit on that system, the bit would not be compiler defined. Why is that important? It means you need to define bits in terms of trits. And therefore, once you do that, you'll be able to use all types, like a uint8 that uses binary, typically, and then have that use, and have that convert to trits instead, right? And that works. Or likewise for qubits, assuming qubits are the atomic units of quantum computers. I don't know if you can go smaller than that, but I assume they are. Then you would also be able to define binary and ternary things in terms of qubits. Or, if you are unable to, for whatever reason, then that conversion simply becomes invalid, and you cannot, and then, as you would expect, you cannot represent binary types, or like binary-based types, with this other type system, or like this other computer system. That makes sense, right? Like, you can't force it if a mapping doesn't exist. So then it's a natural error, a type error, which is very nice as well. With an atomic system, you have natural errors because it's less about the rules you make, arbitrarily, and like I define this rule for this type, but instead just becomes, well, this literally is not representable, therefore it's an error. And that's like a much easier error system as well, because then it's just automatic. The user doesn't have to like define these things that they already know, right? It's just built into the compiler, and the compiler can verify these because it has the building blocks. The one issue is size, though. For example, a uint8 isn't just a value, it's a size, it's 8 bits. It has to take up 8 bits of memory. Whereas an integer, right, just like a generic integer type, I want to, in my language, support a generic integer type that is not tied to any particular size. And then instead have the compiler decide what size is most suitable for it based on whatever optimization makes sense, right? And this is useful to have both, because then I can have an abstract program where I'm like, yeah, well, the compiler is smarter than me, so I'll have it choose the sizes. But then I can also still make low-level programs. For example, the whole reason I'd want to use a uint8 or a uint32 is if I'm interfacing with C code, if I'm interfacing with, like, some game, right? Like let's say I'm modding a game. I need to know what the specific sizes and like the actual primitive types are in order to mod that game. So that's, and I mean, I personally got into modding, to using C++ in the first place was because I wanted to mod a game. So naturally, I personally would want to support both. And right now, it seems like languages tend to only support one or the other. Like Haskell, for instance, has an int type, which is probably like, I mean, I don't know if it's a fixed size, but I believe it will either use a big int or a smaller type if it can. Whereas, you know, and like it does also support smaller types. So, well, yeah. So I guess there are languages that do. Anyway, but yeah. So just think about how to do that. It's also important. But anyway, let's have a look at this video. If it's nothing like I thought it was, then I'll probably just stop watching it. But I thought I'd at least give it a look, just out of interest. My computer's a bit slow right now. I don't know why. Like, I swear something's like really not right. Like, cause again, I've said many times, all these tabs are not.
So today I'm going to be talking about.
So I'll need to look into that. Anyway, this is loud.
Constructive data modeling. But first, just a couple of words about me. My reputation does precede me. I think if there's any particular.
That's weird. I wonder if when I plugged my headphone, because right now my headphone is in like the actual computer. Before, my headphone like plug was inside my microphone headphone thing, and it seems like it was quieter then. It's interesting. Yeah, so let's have a look at this. I'm very curious. The channel here is Software Should Work. I've looked at their channel and they don't have that many videos. And I'm not really interested in that many of the videos either, but if this video is particularly good, I mean, it's not tied to any particular person though. It seems to be more just about like a, yeah, like talks from different people. Now this is new, which is cool. NixOS. So that one actually will stick to my watch later. And this one as well. Like look how many videos they have. Like they have very few. This one would be worth watching, I think. Actually, you know what? Maybe this channel is actually quite good. Yeah. I mean, there's also Andrew Kelly here. This video I had a brief look at. It was more about like not becoming depressed, like literally the black pill of programming, which is, you know, AI will beat us all that. So that's a cool talk. I don't need to watch it, but it's a cool thing that he's done. I think this video too I want to have a look at. Okay, you know what? I'm gonna subscribe because that's actually pretty good. But if I like this talk, I'll also have a look for the person behind it, Alexis King. So let's hope that this is a good video. I've had a good video recently on NeoVim. So, an independent conference on software reliability. Right. So like it's not built on it's not focused on language design per se, but obviously language design is a big part of having software be reliable. And it seems like there are more talks to come as well. So yeah, let's have a look at this.
So today I'm going to be talking about constructive data modeling. But first, just a couple of words about me. My reputation does precede me. I think if there's any particular thing that I'm most well known.
I've heard of this, yeah. But I can't quite remember what it's about.
You probably encountered this blog post. If I had known at the time that it was going to be as popular as it was, I might not have chosen to write all of the examples in Haskell. But I was mostly writing it for my coworkers at the time, and until just a couple years ago, I was actually writing Haskell professionally, in fact, working on the Haskell compiler professionally. But that's no longer true. I decided.
I'm not a huge fan of Haskell. I think there's many flaws that make it kind of hard to use. But like, I still have great respect for people who develop it. Because Haskell wasn't designed to be a practical language. It was designed, I believe, as an experiment to test lazy evaluation, mostly. And then it just happened to also do a lot of other things that are cool and have inspired languages like Rust and whatnot. Or any language features like Rust has. Of course, these features still predate Haskell, but like Haskell was like did like a really good job at making them ergonomic as well, which is nice. So anyone who works on Haskell is automatically very interesting. I think someone who works on Verse also worked in Haskell, and Verse also looks very interesting. I want to look at Verse, by the way. Last night someone was talking about Verse. I need to look at Verse because there's some really interesting ideas there.
That I got tired of that, and now I write product software. I'm writing Scala at a company called August Health. We build software used by caregivers at senior living facilities, assisted living facilities. And in particular, I work on the medications team. And I'm not going to go into too much detail about it because it's very complicated, but I will just say that it is very important that our software works, because if it doesn't, then somebody might not get their meds, and that is very, very bad. So we care a lot about our software working, and of course we use lots of different techniques for doing that, including testing. But the one that I want to talk about today is static typing. Static typing is something that has been near and dear to my heart for a long time. And when I started programming, I kind of feel like we were actually in something of a static typing dark age, where the main languages, statically typed languages that people were likely to be familiar with were Java and C++. And Java is, of course, an infamously conservative language, very, very restrictive and very object-oriented. And so I think a lot of people at the time kind of had this impression that static typing and object orientation were sort of fundamentally connected, with all the pros and cons that come with that. And C++, on the other hand, is very complex, but it's also not really about safety. It comes from kind of this different heritage where types are mostly used to determine what the size and representation of values are, and calling conventions and things like that. So I think a lot of people in this era had this impression that static typing was this kind of old thing that we didn't need anymore, didn't provide very much value. And it's no surprise that when I started programming professionally, a lot of people were very excited about dynamically typed languages, JavaScript, Ruby.
Before I go into this, actually, let me set up my Obsidian, just so I can actually make some notes here easily. Did I think update? Let me check, actually. Oh. Yes! Okay, good. This is the new settings panel. It actually has like a search feature, which is huge. I don't think any of like the actual things have changed per se, but like just that is very nice. Bro, I need to rice my Obsidian setup, because like right now it's really annoying to navigate. New notes. And we'll just start typing here. Okay.
But I'm happy to say that I think in the time since then, we've kind of gone through the static typing renaissance, and I think this is probably best exemplified by the languages Rust and TypeScript. And Rust, of course, is a very, very strong focus on safety, but they also introduced, I think, a lot of programmers to a collection of type system features that were in other languages, but not maybe languages that had seen much mainstream use, and that's really, really nice. And TypeScript as well has a number of features that I think probably most programmers that have used TypeScript had not encountered before, and maybe haven't encountered anywhere else.
Yeah, I don't love Rust as much as Rustaceans do. Obviously, they would love it more, but I do appreciate it for bringing things into the mainstream like this, and like really bringing more interest into like actual good programming language design. Rust could have done way more, which is why I don't like it. I think Rust is a stepping stone to a brighter future, but it in of itself does not necessarily well, isn't that like great? Like it's revolutionary, but the language that comes after it, that succeeds it, will have loads of potential, or has lots of potential to be even better. So I'm very interested in that. Same as Zig. Like Zig as well is in like a very weird place philosophically. I think like even though like right now it's like being built to be perfect, and that's why it's not at 1.0 yet, I think just fundamentally it's kind of flawed. I haven't used Zig, so like I don't have like a strong base to talk about that, but from what I've seen with it, like really rejecting a lot of modern features as well, with like for example not having anonymous functions, like instead having like the actual closures be explicit with structs, like that kind of thing, where it's like I understand what it's like hinting towards. I just feel like it's not executing it in the best way, And therefore, the language that does succeed Rust and Zig and says, I'm inspired by Rust and Zig, in the same way that C++ was inspired by C and Simula, right? I feel like that language will be truly special.
And so, with these two things together, static typing became
You just got to throw out Rust shade.
And so you would
for that
think
reason.
that given that I like static typing so much, I would be very happy with the status quo. I would say, everything's wonderful, and now we can just write safe programs using the type system. But that's not really true. I actually find this situation pretty unpleasant. And the reason for that is that there's been such an extreme increase so rapidly in type system complexity that in my experience, most programmers, say working with TypeScript, don't actually understand the way the type system works. They essentially treat the type checker as a black box, and this results in a lot of frustration, and you'll sometimes hear people talking about fighting with the type checker. Raise your hand if you ever find yourself fighting with the type checker. It's a decent number of people. And so when you find yourself in that situation and you don't understand what the whole type system is, how it works, then you might think, well, maybe I need some fancy, elaborate type system feature. And of course, there's an ever-growing set of type system features. And so it's very easy to think, well, this is just the way it is. This is the way that type systems are. And you just need to, play type Tetris for hours at a time, or maybe ask an AI to come up with some solution. And this is a little surprising because we went from, Java, this very, very conservative language, to TypeScript. What exactly changed that made programmers suddenly willing to accept the burden of all of this complexity? And I think the answer is, well, they didn't really. TypeScript was originally intended to be just typed JavaScript. So lots of people had existing JavaScript code bases. And so they wanted to have types. They wanted to add types to it. And the problem with doing this is that the type system necessarily had to be a lot more complicated because it had to support dynamically typed idioms, like doing something like this, branching on the results of a type of check. And as a result, the type system is much more complex. Like if a language was designed to be statically typed from the ground up, it would usually have some kind of more fit-for-purpose feature. But sort of the idea is that, well, programmers already have a mental model of the dynamic semantics. And when I say dynamic semantics, what I mean is sort of what the program does at runtime, what things evaluate to. And the idea is that if the type checker does its job well, then you can just kind of think about, well, OK, in the body of this if, then x is a string. And so the type checker should somehow magically be able to figure out that that is the case. But of course, this doesn't always happen. And because the type system is complex and it's just trying to not be invisible to the programmer, then when it is visible, often programmers don't really know what to do. And this makes me really sad because we've sort of had this, again, timeline where we've jumped from one end of the type system complexity spectrum to the other one, where both of them are frustrating. Java frustrating because it's too limiting, TypeScript frustrating because it's too complex. People don't necessarily understand exactly what's going on. And this might lead you to believe that the next step here is that I'm going to say that there's some mythical in-between sweet spot where all the problems go away. And I don't think that's entirely untrue, but that's not really what this talk is about. So personally, I don't ever feel like fighting the type checker. Oops, bumped in the mic. I write statically typed code all the time, every day, and I feel very equipped to utilize it to capture any number of invariants that I come across. And in spite of this, I'm actually using substantially less sophisticated type system machinery than I think a lot of programmers are using on a daily basis. But the most amazing thing is that I think that this is possible to do in just about any language that people are currently using that supports static types. Maybe not literally all of them, but certainly a lot of them. So let's make that a little more precise. The main ingredients for the techniques that I'm going to be talking about in this talk require some form of product types, that is, types where you can just kind of combine things together, so tuples, structs, records, any of those. Some form of sum types, so things where you have different variants. So algebraic data types, Rust calls those enums, TypeScript unions, sealed interfaces in Scala. And you need some ability to do exhaustive case analysis, pattern matching on those different variants of these types, such that the compiler will tell you when there are some that are not covered.
Yeah.
And that's it. If you have a language that supports all these things, then all it takes to reap all these benefits is a shift in perspective. So let's talk about what that shift in perspective is. And let's start from the philosophical. What are types? I think a lot of people, when presented with this question, come up with the answer that types are restrictions. And this
I do wonder, actually. Although reflection, I don't believe, has been accepted yet into the standard. Sorry, not reflection. Pattern matching. Although I don't think the proposal has yet been fully accepted or like added to the actual ISO standard yet. I do wonder because like it'd be looking like a C++ 29 feature, and right now we're in 2026, right? But depending on how much people want it, it might even get pushed up the priority list and be implemented sooner. It just depends on, first of all, how much people want it again, and I think people do want it a lot. I think it's really important, and it would drastically change how the language is written, or how code in C++ is written, but also how easy it would be to write or implement, or like how difficult it would be to implement. I feel like it shouldn't be that difficult to implement, or at least I hope it wouldn't be. Like I can't imagine it that pattern matching being that crazy, but maybe it is, and if it is, then we have a problem. But I feel like the pattern matching issue has always been more syntax than actual implementation. Same with like reflection. Like I feel like reflection in C++ isn't that. I mean, like GCC have already implemented it, or at least like a basic version of it in their current compiler, and now I'm just waiting for Clang to catch up. But I feel like reflection is quite low priority for people, because you can't really do what reflection does just with through other means. Although not the nicest means, but like there are reflection libraries. There isn't really a pattern matching library per se. That's more of like a strong, like hard language feature that needs to be implemented. So my hope, basically, I'm coping that C++ gets around to adding it sooner rather than later. Sooner than it has other features. That's my hope. So I guess it's just a question of when will it be implemented.
This is a very natural way of thinking about things, especially in a language like TypeScript.
Like add it to the,
we sort of have this universe of all these values that exist in JavaScript, and we can give a name to the whole universe. In TypeScript, they call that unknown. And then we can draw little bubbles and give sort of names to these subsets, and some of the subsets can even have smaller subsets within them. And so the types...
Okay, so I mean, this is a thumbnail, right? So this is restrictions, actually. Which happens to also form a Venn diagram of sorts, but we have like a global space of all the possible values, and then our types of restrictions. Okay, that's interesting. It's interesting because then it's not atomic. Like you don't build the types; you just determine what you are allowed and not allowed to do, which is interesting. Yeah. I'm not a fan of this model. I do prefer the atomic thing, but even then, you could support both, right? Like, as I was saying earlier about like having those atomic types, but then also supporting integers as just like a general unsized type. I mean, not unsized, but like conceptually unsized, and the size is determined by the compiler for whatever it has to do to represent it.
Basically rule out the things that we don't want. They restrict the set of all possible values. And so this seems like a very obvious way to think about things in TypeScript. But if you really think about it, other languages don't work this way. Like if we look at, say, a class definition or a record definition in Java, if you don't like Java, that's okay. I have some more syntaxes here. And the point is that for all of these different constructs, we're not just defining a new type called point. We're actually introducing a new class of value at runtime, which is this point structure, right? This point class. And so we can actually extend the set of possible values. So we're not really just restricting down. We're not ruling out some negative space. We're actually kind of defining some new positive space. We're building things up from nothing. And this is the first key idea of this talk. It's very useful in a lot of situations to think about the positive space rather than the negative space. So to give a really simple example, suppose that we want to define a natural number type. If we have a language that maybe doesn't have unsigned integers, we might naturally think, well, an int can be used to represent natural numbers, but if we only want to represent the counting numbers greater than or equal to 0, then we might think, well, okay, we need to have some type system feature to restrict the set of potential values.
Yeah.
But the problem is that this is really hard to implement in type systems. There are some languages that support things like this. They're usually called something like refinement types. But it makes type inference really complicated. It makes type checking fairly complicated.
Yeah.
And so a lot of languages don't provide this. And in general, it's very, very hard to do.
Right. So something that I forgot to also mention is you can think of an integer as a sum type. because it's either 0 or 1 or 2 or -1 or -2 all the way up and down to positive and negative infinity, right? In that sense, an integer is a sum type. It's this or that or this or that or that or that or that or that, right? And so you can define, rather than having this, right, you can define a natural as 0 or 1 or 2 or 3 or 4, you know, all the way up to positive infinity. Rather than saying it's just a number that is an integer and has to be greater than 0, right? That's a different way to kind of think about it. And then I can extend this. So I could say that an integer includes the natural numbers. So then that definition of 0 or 1 or 2 is included. But then I'm also going to add -1 or -2 or -3 all the way down to negative infinity. So that's what I was thinking as well, like with that. I wonder what she'll think about.
Impossible to do. So instead, if we could just start from an unsigned integer type, which only includes the numbers that we care about, then it's very easy to go from that to a signed integer type. Now, of course, you wouldn't actually do this because we use 2's complement signed integers. But the point that I'm making here is just that it tends to be easier to add things than to subtract them.
That's true, but it does rely on uint being built in, and uint is also sized. So.
As long as we can just define the positive space that only includes the values that we want, then it's much easier to encode things into the type system. So let's give a few more examples of that. So suppose that you have some list type in your library, and suppose that you want to define a non-empty list type. Again, if you're thinking about things in just kind of this types as restrictions way, then you might say, well, I want to have a list, but I want to restrict it so that the length is greater than 0. But again, that's very hard to actually implement. So instead, let's try and think about what the positive space is. We can say, well, a non-empty list always has one element, and then it also has 0 or more additional elements. So given that this is just a combination of two things, we can just represent that directly as a tuple between one element and then 0 or more elements. We don't need any complex type system features. We don't need some fancy
Interesting. Now this here does actually affect how you also write it though. Like it means that now you have like a head and then the tail of the list, and the head isn't part of the list. Of course this is how you could implement it under the hood and then like abstract over it. But yeah, that's interesting. But also, like, what is a list, you know? Like, if a list is just t and t and t and t, you know, for the size, then a non-empty list can be that as well. But, like, just say that, like, it's t and t and t. But, like, it's t... How do I say this? It's... Restricting. That's the word that comes to mind. Okay. Yeah, so like, this is correct for additive definitions or whatever. Okay, interesting. Restrictions. Because like restrictions are useful. Okay.
way, you know, TypeScript has some.
I don't have to take a note of this. I'll just take a screenshot instead. N for notes. Still adjusting to my new keyboard. It's still it shows the American keyboard layout, so I'm also like writing the symbols from memory. Like hashtag here is a backslash on my keyboard, so I need to also like kind of get used to that, because I want to keep using British, just because my laptop keyboard is also British, and I feel like I'm yeah. Also, like, I'm in the UK, so most laptops I do, or most computers I do come across, will also have a British keyboard layout, UK layout, and therefore, getting used to that is just more beneficial right now. Could I go on a keyboard that just used a UK layout? Probably, but then I would be compromising on how cool this one looks. Whatever. Yeah, that's just interesting. What did I press? Okay.
Fit for purpose feature for this, but it's not actually necessary. Even if you don't have something like that, then this works just fine. And if you say want to define a list with an even number of elements, we can do the same
Well, just TT the list.
thing. We can say, well, in an even list, elements always come in pairs, right?
Oh no, yeah. So it's like a list of tuples. True.
Each time you add a new element, you actually have to add 2 elements. So we can just represent this as a list of pairs. Now, some people look at this and they say, well, this is sort of cheating, isn't it? Like, this is not actually a list with an even number.
Yeah. This feels more like a workaround than like an actual, like, something that you'd want it to be like designed this way.
Of elements, it's just a list of pairs. If I were to call first on my even list here, then I wouldn't get the first element, I would actually get the first 2 elements. And that's true, and you could wrap this up in some interface that you know, redefines all the list methods, but that would be a lot of work, and maybe it's not always worthwhile. The point that I'm making here is just that, in general, if you can decouple your representation from the interpretation of that data, then you get a lot of flexibility, and you can model a lot of things that maybe you would think that you needed a more complex type system to support. So sometimes, especially in a language like TypeScript that kind of doesn't have very many different types, like usually you're just kind of using the same set of arrays, objects for everything, then people will think, well, okay, I have this idea in my head of what my data is, so it has to have that particular type. But of course, this is not really true. Really, your data is just some sequence of 0 or more elements, and you could represent that as an array in many cases.
Honestly, I feel like this way of thinking literally stems from C and like C purists who care a lot about how the interface matches the underlying data. It's an issue you have with Rust as well, because in Rust, like, although like it seems minor, and I've said this many times, the way you have structs and their impls be separate, like, just psychologically speaking, it makes you treat the impls as just acting on that struct data. Whereas, like, you know, and I compare that to C++, where you have the functions in the class. So the members of the class are just variables that are like basically global to the class. Like, that's how you think of them. They're just global, well, not global, but like they're scoped global values, let's say, variables, and you can use those in your functions. But they do not define the class itself. But with Rust, when I have my struct, I see the struct as just the data inside the struct. So then when I invoke the struct, right, and I create it, I instantiate it as an object, all I'm really thinking about is the struct. The functions being separate just like make me think as a function as like ways I can manipulate the struct data, when it shouldn't be. It should be like an abstraction. And I feel like that really hurts Rust, and it's something that people haven't really talked about, but something I've pointed out many times. While this does make implementation easier, according to the speaker, it does feel like a hack. As if a better designed programming language would not have a need for this. Yes, you can, that being said, as long as you can wrap this in an interface, that makes it appear natural to the user, even though I love how I'm making like almost no typos. It's the mechanical keyboard. Even though the underlying data is different, it's quite nifty. Okay, and then actually, a separate note for this thing. 1122, seriously, 1120. Oh my god, I need to remember my keybinds. Why are you doing that to me? I need like a keyboard pad, low key. Like, because my keyboard's elevated, like I would benefit from having some elevation on my wrist as well, so it's not pressing against the table here. I was to get a keyboard that had it, like came with it, and I'm realizing why they came with it. But perhaps I can figure something out. Same for like a mouse pad, honestly. Although I feel like my wrist hasn't struggled too much for the mouse. It's more for the keyboard because of how the keyboard's elevated. Anyway, I feel that the mentality that data must represent a type's interface should reflect its internals comes from the philosophy around languages like C and Zig. Even in Rust, I've struggled with the design of structs being so that the functions are in a separate impl block. It's although it is functionally functionally the same as C++ classes, you know, in terms of having functions tied to a class or tied to a struct. Psychologically, it feels as if the functions are separate, because they are written as if they are an extension of the struct. Yeah, that's right. An extension of the struct. I need to get my Vim keybinds on this, bro. This has the effect of wanting to have the struct's interface reflect its internals. It doesn't help that Rust has two ways to construct structs. Static methods preferred, and raw foo calls. Yeah.
It might even be possible to represent it as a set or a bag. But similarly, if you think about, well, my data is just a sequence of one or more elements, then this representation is very natural. And so it's very important to get away, I think, from this idea that there is some privileged, correct, ideal representation of your data, and instead free your mind and be willing to come up with some other representation. So let me give a slightly more complex example. So suppose that you have some user structure, and a user can have an email or a phone, or both. But at least one must be set. And so if you're imagining, well, this is just like the structure of my user class, maybe it comes from my database, I have 2 columns, and this is just generated, then in this case, it's hard to enforce this in the type system. You might say, well, maybe I need some fancy dependent typing thing where I can say, well, the type of the phone number depends on the value of email. And again, it's very easy to get kind of lost down this kind of rabbit hole and start thinking, well, in order to restrict my data, I just need fancier and fancier features. But of course, this is not really necessary if you're willing to just introduce some additional type, some enumeration that defines exactly which possible states there are. That's not too bad.
That's pretty good, actually. Yeah.
I don't know why. It just sometimes happens where the text disappears. Don't worry about that. But in this particular case, we don't need that comment anymore. It's just enforced in the type system. And if this is a lot of boilerplate, then obviously you could introduce some abstraction to say I have one value, some other value, or both.
Yeah, the main thing is definitely boilerplate. It could be just be a hassle to kind of do it this way. And like the intent is clearer when you just say if whatever, right? Now this okay, maybe not or, but like this example here is particularly attractive. I do like this a lot. I think it's an elegant solution, but yeah, like just having like making this easier, I guess should be the focus. So in fact, let me take a screenshot of this one as well. Should I screenshot this or just write the code? I'll screenshot it. Doesn't really matter. These are just loose notes anyway. I mean, not loose, but like they're just notes. This is big. I think they added resizing. If I'm not mistaken, like to Obsidian. I don't know how you do it though. Is it Alt? No. Control. Shift. Windows key? No. Let me check the Obsidian patch notes real quick. Obsidian patch notes. Or the changelog even. Oh! Got my contract. I guess checking up on that was good. Let me unload this in case I leak something important. This was July 30th. Desktop, yeah. So settings were new. Images, okay. Yeah, so the easy resize can be full screen. Click an image or the zoom button to open it. Okay, I mean that's a live editor. Huh. And there's also Vim things, that's cool. Or how does the Vim thing work? Oh, Vim mode, right. Okay, no, yeah, that's fine. Should I just enable the Vim mode? The issue is like the Vim mode has no line numbers, nor like relative line numbers. So like you're missing a lot of the niceties that make Vim kind of like more efficient. Because like you need to have these features to make it more efficient than they're using a mouse. Otherwise, you're just like spamming the keys. Okay, like is this only in live preview mode? Yeah. That's cool, but people have asked for this to be in just normal mode as well. Like view mode. How do I even enter the other mode? Do I have it like disabled? Wouldn't mind this being an overlay. I'd like if I could toggle that. Live preview. Image. Nope. Yeah, we got reading view and editing view. What? Alright, so I gotta like choose it here. That's default. How do I switch between live, what's it called? Live preview. How do I do that? Is this? No, that's just reading view source mode. What? Now am I in live mode? Yeah. No. Yes. Okay, so now I'm in live edit mode. But I don't like live edit mode. That's my CSS plugin. Don't worry about that. So it is here, and like here's the resize button. But like I don't want to have to be in this mode because I like source mode. So why can't I just drag it here, bro? Whatever. Good news is you can still just enter things manually. Now where is my bar? I don't actually know where my backslash is yet. Like, I don't know where it's been mapped to on my keyboard. I don't know if I even have it on my keyboard, to be completely honest. Yeah, that's that. Because usually it's to the left of my Z key. But my Z key doesn't exist. Sorry, the thing, there is nothing to the left of my Z key now. So there's a non-zero chance I literally just don't have it on this keyboard. And that would be problematic. I got the brackets here. I've got these two symbols to the right of my L, but then the one after that, the hashtag, is above my enter key instead. So that's been moved. Then I got these three next to M. Yeah. I might literally just like not have backslash. Because the pound sign is removed, and so is the euro sign. So that key has been like replaced. And because of that, I think they just don't have it. Which is really problematic. There is alt though. I think like alt will yeah. There's bar there and backslash. Yes. Don't know about backslash, but there is a bar here at least. I think it is anyway. Yeah. So that's a solution. But I don't know where backslash is. I need to kind of like find that. Or just switch to US layout, but... Should I? Maybe I will. I'll do it later. God damn, bro. Why can't things just be simple? So with this code, this is an elegant solution. Okay. That was a misclick. So did I close it? No, it was here. Yeah, so also, because my hands are not elevated on my keyboard, I am more prone to misclicking like the Control, Win, and Alt keys, which can obviously do things that I don't want to do. So yeah, this is something I need to figure out. Like, I can feel my wrist, like, in pain, which isn't supposed to happen. Let me try, like, a sarong or something. Okay, that's pretty thick. Yeah. A little makeshift mouse pad here. This is an elegant solution. Although it does require some boilerplate in most languages. I think we should therefore be motivated to allow this this pattern, let's say, for less boilerplate. For example, Suppose in Rust you had your structs like this instead. So literally, yeah, so like have a struct user, right? Have your ID int, I guess. But for your contact, is this even Rust or is it like TypeScript? I can't tell. Or like Kotlin or something. But instead of having this, have it be email address or right or phone number or right. This is hard to get used to. Email address and phone number. So email address and phone number. If that's our tuple, let's say. Right. So like now it's in line and it's pretty straightforward. No extra boilerplate. Of course, you do need to know what email address and phone number are. Those have to be defined, right? So maybe like an email address string, a phone number int, like email address string, and a phone number int. Or even, for this particular pattern, as she kind of shows, but different way. So again, ID int, same thing, with a contact, it would be something like email address, which is a string, and or, so and or phone number. Right, very simple. So now these are just connected. And to make that more explicit, I'll put an and here. Right? So so now this is just like way less boilerplate than this. Cool, right? But let's assume that we don't have the types here, because she doesn't do it, so just help it be a bit more easy to understand. Oopsie, that was a misclick. I have so many tabs open as well for fucking Obsidian. I really need to just switch to NeoVim. Ready to go. Did I close it? I did. All sources, untitled. Yeah. Like, look at that compared to this. And, you know, that's because you can do this to create a type, an enum type in line, which is very handy. I mean, I think this works in Haskell even, and similar like ML languages. I don't know if they have this, but this would just expand to this.
Obviously, you could introduce some abstraction to say I have one value, some other value, or both. Haskell calls this type these, which I always felt like is not a very useful name. Scala calls it IOR, inclusive OR. But I actually often like just keeping things simple and having just some fit for purpose type, and that's because then if this type changes in the future and now all of a sudden we need to introduce some new field that says, well, maybe this is a system user, which doesn't have an email address or a phone number at all, then we would introduce some optionality here, and then again we're back to the comment situation, but again we can just instead update this type and say, well, there's some fourth case.
Yeah.
So in general, if you're willing to really think through this and just think about like how could I actually model this in such a way using these tools that I'm only going to include the values I want, it is possible to express a lot of different things. Sometimes though, it can actually be pretty tricky. So it's definitely not always obvious or always free. So for example, suppose that we have some time range type where it has a start time and an end time. And we want to have some invariant that says that the start time is always less than or equal to the end time. So we don't ever have negative time ranges. How could we, in theory, represent this without some fancy type system feature that lets us express these restrictions? How could we represent this constructively, where we're only defining the positive space? Anyone have any ideas?
I mean, take the absolute value, right? Which I guess makes sense. Like, it's not the most nonsensical, because it's a time range. So like even if you shuffle back in time, it's still like a range is like a distance. So
That's right. So we could instead introduce. Oh, I've lost focus on my slides somehow. That's not good. There we go. We can have a start time and a duration offset. So it's not always.
okay, that's probably better. But it means that you can't just take note of the end, right? Which is mildly concerning. But yeah.
Always like the most obvious mechanical transformation, but it is often possible to do. And that's not always true. Sometimes maybe it's not worth it. It's not possible, and you can just introduce some abstract type. But in many cases, it is. But of course, there's often many different representations to pick. So I think another question I sometimes get is, how do I know which one I should choose? And from my point of view, this question can be answered by really considering, like, what is the type system actually for, at least from a correctness point of view. Obviously, there's lots of different uses for the type system, things like tooling, autocomplete, performance optimizations. But I find that when I ask this question, I actually get a lot of different answers. Sort of people who don't really like static typing very much answer things like, well, you know, it prevents you from adding one in a string. And I mean, that's true. You know, in some situations, that's actually kind of useful. But I think if the type system were only doing that, it probably wouldn't be worth all the ceremony. People that are really into static typing, they say, oh, you know, it's about formally proving my program correct. And let me tell you, if you were formally proving your program correct, you would know. You are probably not doing that. In the object-oriented days, you often had people who liked to be taxonomists, where they would go around in their product domain and find all these different nouns, and they would come up with a class for each and every one of them. And don't get me wrong, domain modeling is a very useful skill, but to be honest, it can be done in a dynamically typed language. There's not really any need for static typing, although it can be helpful. So I think the most common answer I get these days, especially from sort of TypeScript programmers, is, well, the ideal is just to write the right type of my data, right? I want to have the maximally precise specification, and the more fancy the type system gets, then the more precise I can make my types,
Yeah.
and that's good.
I mean, I guess my answer is not allowing nonsensical not allowing nonsensical values to be representable. And also operations. Like if I intend for something to be something, then I don't want it to be something else, ever. So like that's what I would think type system is for. And that's why I get annoyed if the type system doesn't let me go all the way.
But I'm actually not sure that it's good. And in fact, I think the answer that I give is really much simpler than this, which is just that the type system keeps track of the different cases that you have to handle in your code. So let me give an example that illustrates this. So suppose that you have some user type enumeration where we just have standard users, admin users, and system users. Then we have some producers somewhere in our code that are actually sort of using these different types. We're creating users with these different types of privileges. And then somewhere later in the code, we have some authorization function. And the key point here is that these two things can be really far apart, right? There could be some complex, twisty sequence of calls, could even end up in a database and then be read back out of a database. These two things are not close together in the code, but if we were to still, you know, need some new type of user, maybe we add a new type of API user or something like that, then our type system, as long as it has the ability,
will give you errors, yeah. I mean, exhaustive pattern matching is great, largely for that reason. Let me just change this to Scala before I forget. I like how that somehow made this highlighting worse. Actually, no, it's good, actually. It's more minimal, which is good.
to support like ensuring that our pattern matches are exhaustive, then it will tell us immediately when we add that usage, that producer somewhere, it will tell us all the consumers that we have to update. So from that point of view, a type system is really this sort of obligation propagation machine, where you are just, each type definition sort of relates the places where you produce values and the places you consume values, and it is those use sites specifically that inform what the obligations ought to be. And this is, I think, where a lot of people seem to get tripped up. So let me use a somewhat more realistic, a somewhat more concrete example. At work recently, we've been dealing with sort of counting of inventory of medication. So ensuring that, say, narcotic drugs are not being stolen from these communities. And so we keep track of an inventory log, which here is just represented as a list of inventory log entries. And each one of those has some change. So, you know, received 20 pills, administered 1. And so maybe we want to get the total number, and so we're just going to send them all up. Now, it turns out that in our particular implementation, we never actually have an empty list of inventory log entries. If we have any inventory log at all, we are going to have at least one entry. So we could, in theory, make things more complicated and use a more precise type and say that this is actually a non-empty list. But the list type is used everywhere, and it's really convenient. And so given that a sum, in this case, is just going to actually return 0 in the situation where the list is empty, it's really no big deal. And we can just use the plain old standard list type. But in a different situation, suppose that we have some other function where we just want to get the most recent entry, and we want to get from the most recent entry the most recent timestamp. Then in this case, if we were to use just an ordinary list, then we wouldn't really have any way to handle the case where the list is empty. And in that case, maybe we would insert some panic that just raises an error and says, well, that should never happen because the invariants say that it should never happen. But the problem is that as soon as you do this, as soon as you introduce these kinds of error conditions, then that is something that your type system cannot guarantee will not happen, and so it could, in theory, happen in the future. So in this situation, maybe it's worth it to strengthen that type to a non-empty list. But the point is that's only useful here because we're actually using this operation that otherwise could fail. And there is no need to strengthen the types. There's no need to make them any more precise than they need to be, except when you have these situations where otherwise there could be an error raised at runtime. So this is you have.
Right. Yeah. I mean, I see what she's saying. Like, these are functions, so like it's just a question of what does this function do and what input is logical for it to be able to compute. Because like you like either way when you're writing functions, you want it to be as generic as makes sense anyway. So like if you make like a function called calculate total, but you only like, I don't know, make it fit your specific use case, so that's just that if down the line you wanted to use it for like something else or like something similar, you'll be like, wait, for some reason I can't calculate the total of an empty list, even though it should be 0, like for instance. Like, that's just kind of restricting it for no reason. It's different if like you have data that's like, I need it, like I want it to be this because it is this. That's different. Like an is-a relationship is different. But for a function, it's like a operates-on relationship. If it can operate on an empty list, there's no reason to restrict it. Unless like the function itself has a different purpose. Like calculate non-zero total. In that case, yeah, obviously it should be a non-zero list. So this seems quite intuitive. But yeah, like restrict it when you need to restrict it. In particular to avoid panics. Yeah. It's why I'm not a huge fan of Unreachable. Like standard Unreachable for C++, or like Unreachable for Rust. To me, yes, it's a good tool, and like obviously I'm happy the languages have it. But like I mean more like I don't like the fact that the language is designed in such a way that it needs to exist. Like there should be a way to just have it for the language to not need that kind of like manual, this case cannot be reached if it does panic. Like that shouldn't be in your code. It should just be very natural where it's like, yeah, obviously it's not, reachable. I said non-empty list,
These situations where otherwise there could be an error raised at runtime. So this is actually the third key idea, which is generally pick the easiest representation, the simplest representation that allows ruling out these cases where things just shouldn't happen. Another way of putting this is that it's useful to write.
Yeah, yeah.
It's total functions. This is something that in functional programming we think is very lovely, and it's true that in functional programming languages, more, say, standard library functions tend to be total. That is to say, they return a value for each potential input.
Oh,
They don't just raise an exception. They don't just throw.
right. Yeah. Yeah, that too. Just means safer things. And it also means like you don't have to return like an optional or something as well to like get around that. I need to handle something real quick. Yeah, got a DBS form coming to my house apparently. Cool. So I think I need to sign that, so then I'll be able to finally get my contract for my job. Hallelujah.
Get a lot more value out of your type system. Now, one additional example that I kind of want to walk through here is option types. So option types are really great, and even in TypeScript you can kind of have option types. They don't really use option types in the traditional sense usually, but the point is that there's just some way in the type system of tracking optionality. And I think a question that I'm not sure very many people I know have a compelling answer to is, which is more restrictive, just some value t or option of t? What do you think? Show of hands, how many people think that it's t is more restrictive? How many?
What does that mean? Definitely T, right? Right? Surely. I mean, like depends what lens you're talking through.
People think that it's option t that's more restrictive. Much smaller number. And I mean, this is kind of a trick question. Like in some sense, certainly the set of potential values, the positive space of option t, is larger. But really, it depends on how we actually go about using these values. So for example, suppose that we have some function, and we're going to use this function to notify when some failure happens in the system. So this is going to take an option user, and it's going to be very easy and convenient. And this is great because then when we're implementing some function where maybe we don't have a user on hand, maybe we have some unauthenticated endpoints, then we can just pass in none. And so this seems like we're being very generous and not particularly restrictive. But of course, the problem is that then when we go to implement the function that actually notifies some user about the failure, when the case is none, then we don't really know what to do. And I find that when I end up in this situation when programming, it reminds me a lot of this particular tweet, which I find very funny.
That's actually gold. That is actually gold. Okay, bro. That is for the ages. Gee.
So maybe using optional types is not always less restrictive. Maybe it's actually more restrictive. So let's try again. Let's instead implement the functions in a different order. And let's start by implementing this notify about failure function. And because it's much easier, we're going to make it not optional. But of course, in this case, we've actually just pushed the problem to this other function where now all of a sudden we have to decide what we're going to do in this particular case where we don't have a user on hand. But there is one key difference between these two things, which is actually quite useful, which is that we've actually moved the obligation of where to handle the failure from one place to the other.
Yeah.
So by changing the types, we're able to decide, and this is kind of the parse don't validate idea, by changing the types, you can move where the different failure conditions actually end up happening. And that, to me, is really such a big point of modeling your types in a particular way. In some cases, they might have a lot of different cases at the sort of input to your program because there's lots of different failure modes. But then once you've handled those failure modes, then you can narrow the set. So just to recap what we've seen so far, defining your data as positive space is very good rather than as negative space. Decoupling your data representation from its interpretation is very helpful.
Just a side note, sorry. How did she get her job? Working as like, does she work in the company that like does the prescription software, or like at least like does the prescriptions, or was she talking about like a particular thing she was assigned to? Because like that's a really cool job. Like that's like exactly the kind of thing that I would like to do.
Using type definitions to encode the obligations necessary to write total functions allows you to basically take advantage of the type system to prove those invariants rather than just have a low confidence guess. And then you can change your types to push obligations around to the places best equipped to handle them. And this is a very simple concept, but in my experience, I see a lot of people who say have read parse don't validate, and they get very confused because they think, well, I need to have some email address type that then pins down the type of every email address everywhere in my system. And I don't really understand why people feel that that is necessary. I just represent email addresses as strings because there is not actually any situation where I would need to look at the structure of an email address. I'm just going to hand it off to my email service. So the way that I think about it is I just want to make my types as simple as possible, but no simpler.
Okay, there is an interesting argument there. I mean, like she said before, it really just depends on where you want to shift the responsibility, or even like how early down the chain you want to handle that, address that responsibility, right? Like, say I have a give, I don't know, bro. Say I have like a user, right, struct, class, whatever, a user type, let's say, type is a good general word, and it contains an email field, right? And now there's a function called send email that will send the email with my email address and send it, right? Now the send email function sorry, train of thought got absolutely wrecked. Yeah, sorry. So the send email function, right? It needs to have a valid email. So do I have the send email function? But the thing is, the send email function is like it draws from. Like it doesn't take input. Like the input is the struct, right? It is the type that it's being, well, that is calling the function from. So in that sense, you do need to have the email be type checked on construction of the type. Or like if I have like a set emails method, like that should actually check it and not just accept a string. Because it has to. Otherwise you're gonna have errors down the line. Or you like throw exceptions from other things, which is not what you want either. Well, sorry, it's not, yeah. So restricting the type to what makes sense just seems right. Like as simple as possible, but no simpler. But it's like, well, you can do that, but you might face issues down the line for not addressing things when it makes sense to address them. Like if I want to accept an email in my field, I would prefer it is an actual email, so that anyone who tries to use that field doesn't have to worry about like validating it. It's already validated. Like that's just a more like a useful thing to do. I don't know if that's goes against what she's talking about specifically. Maybe she had other examples in mind. I guess we'll find out as well. She obviously has more experience than I do, but yeah. The way I've just explained is what I would like, is what I prefer personally.
So one final point that I want to mention here before I open things up to questions is I I want to make it clear that I do not think that fancy type system features are bad. Fancy type system features provide an awful lot of convenience. For example, going back to the non-empty list example, TypeScript has this feature, which I think they call like variadic tuple types, where you can do this sort of splat, this spread operation. And this allows you to model a non-empty list. And the thing that's really great about this is that, I mean, it's an array, not a list in TypeScript, but the point is the same. This still allows you to just use all the methods on array, and it's very easy and it's very convenient. This is not a bad thing. This is great. If you have access to a feature like this, by all means, take advantage of it. Just do not get caught up on it and start thinking, well, you know, this means that we absolutely need to use those things to model all kinds of invariants. And if your language doesn't have some fit-for-purpose feature for keeping track of something like this, then it's just impossible, and the type system needs to be improved. We need to have dependent types. That's not really true. And that's it. That's all I have to say.
Holy Q&A session. Okay, cool. Yeah, cool. An interesting talk. An interesting talk, which is what I wanted. Hold on. So let me check out this blog. Lexi Lambda. Actually, I guess I'll go Twitter first. Why is his name familiar to me? Alexis King. Am I thinking of like some other person that's just a similar name? Computers can be understood. DMs open. So there's a blog link, which is why I put it here. 1997. So she's 9 years older than me. She's 29. 29? Damn. That's young. Because like usually when like I watch people give these talks, it seems to be people who are like in their 40s or 50s. But that's quite nice having someone younger that I can, you know, gives you more hope that like the jobs, all the good software jobs aren't already, you know, given away to, well, I don't know, yeah. Is this the blog? From YouTube. Oh, these are languages. HTMX. There's a HTMX guy here. Okay, I didn't realize that. SQLite as well. Okay. Some good talks then, I think. I don't know what that is. Think being online has radicalized me against reflexive contrarianism and irony poisoning. I can inform no question in my head at all times. Irony poisons low trust fascism. I don't care if it's cringe, you have to believe in things, earnestly to acknowledge that progress is happening, and better things yet remain. You lull them out, everything is death. We must allow ourselves to believe that there are things in the world that are good and beautiful and true, and that they are worth defending and fighting for. Okay, let's have a look at this blog. Oh, is there a listing? Yeah. A break from programming languages. Last blog post was over 4 years ago. She's right. Last talk was almost 2 years ago. But she made one this year. It's interesting. That sounds interesting. Haskell type limited programming. Names are not type safety. Right, good for Haskell in particular. Types as axioms or playing God with static types. Right, here's the part to validate. I don't know if I've read it, but I've heard of it. Empathy and sort of experience in programming languages. Huh? Have a look at that. Specifying one database control. Defining rackets separate compilation. Right. Wait, how old were those Twitter posts that I was reading just now? I could expand anywhere with local apply transformer. And there's a lot more. It's like a list of like just the titles. Perchance. This is home, right? There's our GitHub. Blog uses Scribble. Okay. Is Racket their own language? I can only assume. Right, I'll have a look at these in a bit. There's a website. 151 repositories. Awesome. What is Racket? It's her language, right? Yeah. And she has a lot of things in it. I've heard of Racket. I think. Yeah, it's like a Lisp type thing. Does she own it? Or does she contribute to it? It's forked. Okay. Yeah, okay. Jeez. But she seems to have worked in Racket. To some extent. Man, this was like such like a different world. Like I've been thinking about like how to get into it, but like I just don't like Lisp that much. Like I thought Emacs would get me into it, but then I didn't use Emacs, so I guess I'm waiting for like the next excuse to learn it. But like not excuse, that next reason to learn it. This is her dot files for it, just general. This is Vim with, yeah, 10 years ago, Jesus Christ. I can only assume these are no longer used. Or she doesn't use Vim anymore. I don't know. Anyway. Then this conference. So creative Z, creative Rock, SQLite, HMX. Software/CV. That's your name, right? Why is it CV? Oh no, that's his CV, right? What was his talk? They don't link them here, do they? Oh, they do. Has he talked yet? No. Carson Gross. So I wonder what he will talk about. Because HMX is quite an interesting language, just because it's like literally not replacing HTML per se, but like giving like a viable alternative to HTML in the same way that like I don't know, JSX is an alternative to JavaScript maybe, but probably like better even. I've heard of Phil C. I forget what it's about though. That's Philip. He also doesn't talk. No, he did. Phil C. Garbage in, Memory 50 out. Okay, maybe that is worth watching then. I mean, I'm sure they all are, but like specifically watching. Okay. Yeah, she's a software engineer at August Health, which is a very cool job. SQLite, that's Richard Hipp. No talk yet. Andrew Kelly did his talk. I wonder if he'll do a different talk, or if he's only going to do the Black Pill one. Because like the Black Pill one is like inspirational, but I want to hear more about Zig. Sponsors, tickets. Oh, 499? Bro, what is going on here, bro? There's a schedule. What? It's over, right? Yeah. So these talks are over. They're just uploading them a bit late, I guess. It started with Andrew Kelly. Does he do another talk? No. Okay. And they don't seem to be in order. AI and the university. That'd be interesting. It's something like it's about university. Saturation, how software fail scale. I've bookmarked, or I'll put that in my watch later. Code worth writing. Sounds interesting. Be careful when improving performance. Might be something interesting, or there might just be something I've heard before. Why should you create your own DSLs? Interesting. I just wanted a non-blurry screen magnifier. Sounds interesting. Are these links? Okay, let's look at this one. Oh yeah. The last year has seen the dramatic emergence of widespread AI-based coding practices. This has shaken many developers' faith in computer programming, both as a career and as a vocation. And it shook university departments in computer science. Students are using AI to complete assignments. Yeah, I know it. It's annoying because it means like more things when I move to the exam, and you get less chance to like focus on things as coursework. In fact, my computer systems exam, which for the record is like assembly, Linux operating systems, and like C code, like stuff like that isn't particularly easy to memorize, or like Windows process IDs, like that kind of shit. That was 100% exam, so like that was mildly stressful. I spent like the 4 days before the exam literally going through all the lectures, like the lecture recordings, and taking like notes in them, because my memory is like somewhat decent. So yeah, I just did that, and use like Claude and Gemini to generate practice exams. It wasn't that stressful though, because like I did like enjoy it. I do enjoy that topic. But like imagine if like you are that interested in like assembly or C or operating systems, that shit's stressful, man. Like I'm lucky because I like that. Okay, that'd be a very cool talk. Food guide. Cool. Cool. Right. So it's like a Q&A for this. Hold on, go check my email. Right.
Questions? Thanks, good talk. I have tried to use something
Is that Andrew Kelly?
called the type state pattern in Rust. Have you heard of this? This is like...
Yes.
Okay. When it keeps you from calling certain functions when the enum's in a certain value. Have you ever tried to make this ergonomic and ended up being awful? What are your thoughts on it?
Type state Rust pattern. I don't write much Rust, so I'm not familiar with all these patterns. Yeah. Drop is a very interesting function. Like, it literally does nothing. But it does something just because of the language semantics, kind of. It's cool. Compile error. Okay. So, like he said, it's making certain functions just unusable. Right, yeah, so I guess because like with Rust move semantics, if it just goes out of move, then you can't use it. But like that's only if it's that's only like if it's a situation where it doesn't exist, right? Yeah, it doesn't work in other languages because, well, there's no bar checker. Is that it? Is it just for living and death, or can you do it for like actually for other states too? I guess you just like take advantage of it. I don't know. Okay.
Yeah, that's a good question. I mean, I think the way that I feel is that there's lots of sort of benefits to using type systems that are, or using type systems to model particular things that really do just tend to be a matter of sort of usability ergonomics. For example, like sometimes people will like to introduce type wrappers for different types of IDs. Like maybe you have a user ID and a post ID or something, and you don't want to confuse those. Or another example that people sometimes give are like keeping things with different units distinct. And that definitely does, I'm going to fall off the platform here. It definitely does help to avoid accidentally confusing those things, but it doesn't really add type safety. It just sort of adds a speed bump. Now, a speed bump can be useful, but it can also be annoying, right? It really just kind of depends. So I think for those sorts of things, like the examples that I'm trying to focus on here are that this is like a concrete case where it prevents you from writing, oops, I needed to have the value be in a particular form, but there's some case that I don't want to handle. I find those much more sort of unambiguously useful, but there are other cases where like if you make a particular mistake a lot, maybe you want to introduce a speed bump. So it really kind of depends on your use case and what the team happens to be. It's up to you.
What are your opinions on in OO languages where you have interfaces, for example, mutability of collections? So for example, you might have a concrete dictionary type that's mutable, but actually the function or the data type only requires like an read-only dictionary. So I saw a lot of things about concrete arrays, but what happens with OO languages that have these capabilities? For example, F# has some types, product types. How do you reconcile that with these OO or interface-based systems?
I'm not sure I entirely understand the question.
So when thinking about representation and interpretation, you can think of like interfaces as a way of specifying the way they're interpreted.
Yeah.
So would you focus on specifying concrete types or specifying just the interfaces?
Yeah, that's a good question. I mean, I definitely think that like this particular school of data modeling involves concrete types. And I think part of the advantage of using concrete types in this way, where you're able to pattern match on things, for example, is that like let me maybe give an example of this. It's possible to, let me jump back to here. It's possible to have, say, a definition of the non-empty list where you instead use an abstract type. And in the constructor, you just verify that this property is true.
Yeah.
And then if it isn't, then you either return none or you throw or something like that.
Yeah.
And then you only expose methods that maintain that invariant. And in some cases, that's super great. And in some cases, it's actually much easier to do than trying to model it in this sort of concrete way, because then you can just use some arbitrary property, and arbitrary Boolean properties are very powerful. The problem, of course, then, is you now have this like surface area where you have to maintain the invariant. Now, for something like this, maybe that's really, really easy. But something that's really great about this is that it is impossible to break the invariant, right? There is no sort of blessed code that has to worry about it. So I think people often conflate these two things, but this is a stronger property, and the other thing is that it allows you to kind of directly benefit from it. Like, you can just get the first element, it's just there, it's available to you. Whereas in the case of like you have some abstract type, maybe you can define a method that gives you that first value, but of course it's going to be just like getting the first value out of the list and throwing if the invariant is ever violated.
No. If you use a constructor that rejects rejects unwanted values, that should work fine. There's no exceptions that needs to be thrown because it only accepts lists that worked in the first place. But yeah, so the difference is that you do have to model around it, right? Like let's say I want to empty my list, I need to redefine empty so that it only empties yeah, so it only empties up to the, I don't know. I mean, like, I guess you wouldn't even be able to empty it. Like that method just wouldn't be supported. Yeah. Or like you can remove elements, but you cannot remove the last one, or like something like that. Like you'd have to define those. Whereas for this, it's like, well, that's the first element. So like, yeah, I mean, it's more convenient to do this, right? But I do feel like having the full setup and making that full setup easier to write with less boilerplate, I feel like that is just the better solution overall. I like what she's saying, but it seems more like a workaround for languages that don't support such power without the boilerplate, or even at all in some cases. But yeah, I don't know.
So it sort of is, that is a technique that allows you to model things that doesn't necessarily rely on the language, whereas this kind of integrates the invariants more deeply into the language. So I tend to prefer this, something that doesn't require me to worry about some blessed surface area, but I mean, both are useful techniques.
Hello. So you used an example of, constructively representing a time range as like a start with a duration rather than a start and an end time. A kind of maybe obvious objection to this is, oh, well, now every time I need to know what the end time is, I need to do a computation. But the benefit is that like I can make sure that this invariant is enforced by the representation here. Is the when we think about like in runtime, if like we need the end time a lot, like should we be expecting language runtimes to, privately memoize end time for us? Should we be doing this ourselves? How do we kind of reconcile this maybe more constructive representation with the performance trade-offs?
She said that, yeah, there can be a trade-off in performance. So I see what she does here. But also, that got me thinking. Again, like with those constructor level exceptions or rejections, if you have a return an optional, right? So a constructor that can return an optional or a result type, whatever. You need to verify every single time you mutate that class. You need to do a re-verification, basically. So either you define methods such that, or like either you define the interface such that with all of its methods and whatever, there's no way that it can enter an invalid state, in which case fair enough. But the easier option would be to just have a non-zero list and have a constructor that just says, okay, it must be more than zero. The left must be more than zero. And then every time that list is modified, so if I clear it, if I try to remove it, or remove its elements, it checks. It says, okay, is the constructor condition still upheld? If it is, then fine. If it's not, then error, right? But then it's like, well, we don't want to have runtime errors for no reason like that, or like at least like that excessively. Even in general, we prefer to have things known at compile time, right? Compile time errors. So, but also, hold on. It's a hassle to have those checks for null state every single time you call a function, especially when like the function returns a value. Even like I could have like a function that mutates it, but then returns a different value. Like I can't really build that into the return type. It doesn't really work that way, and that's where exceptions come in. Like it's the same issue that like C++ style constructors have, in which they do not return a value but the type. So you can't like return an error value. You have to return you can't return a value as an error. You have to throw an exception. So then the solution is do not use normal constructors if it can error. Just use a static function that does the same thing, like a function called create, that, or build, or new, well, not new because that's a keyword, or I'll make, right? So then instead of just calling foo constructor, I call foo make, and then that can return an error. But you can't do that for everything, because again, like if I have a mutation going on, like do I have everything return a result type? Right? Where like one of the errors can always be invalid state or something like that, like entered invalid state. And you could do that, but it's a hassle. Especially without error propagation. In Rust, it gets by better because of the question mark operator. But that's why for true, I kind of want to move away from that, like the option error handling for invalid state, and instead build it into the type system, but also like verification. So like, because again, you can either return the error or write the function in such a way that it cannot error. I prefer the second option. Write the function in such a way that it cannot error. And to do that, you would have the compiler enforce that if the compiler cannot verify from what you've done that an error cannot occur, then you have to handle the error case. Yes, it makes, it makes quick iteration harder, or like iterative programming harder, because maybe like you just want to test something and like you don't really care if it can error. So I would need to figure that out. But like just like generally speaking, let's say I call foods constructor, right? And like foo has some kind of condition that needs to be met. If it's not met, then it returns an error. Sure. But then let's say so that if I call the constructor, which doesn't return a value, by the way, it doesn't. But if I in this case, let's say it's just like a void constructor, or not a void constructor, but like it only returns the value, and like not optional or anything, like it's just the value. And if it doesn't work, it would just crash the program. So then because of this, the compiler would pick this up and tell the user who calls the constructor to ensure that the input is in a valid state. So something like that. But then you would still have the option to also return an optional instead. And that would still satisfy the compiler, because at least you've handled the error in some way. Having the error result in an optional is still error handling. It just means that now you need to also adjust the optional. So like that's what I'm thinking, because like then like it just forces users to handle errors and not have crashes. That's it really. But then how they go about doing it, I guess that's where questions like these will come in. Yeah, I don't know if that even made sense, that rambling, but I'll explore it later.
That's a good question. And I think actually, like, one of the things that is interesting about this particular example is that it's not entirely consistent with what I was saying here, which is that modeling this particular constraint constructively doesn't necessarily reduce the number of cases that you have to handle in the code. There's not necessarily a situation where you would have to write, like, given the top representation here without that restriction invariant, you wouldn't necessarily have to throw. Situations in which this has come up when I've been working on code is seeing, well, okay, maybe I actually want to get the duration, and I care that that duration is positive. So in that case, it would be very nice to have this bottom representation because the duration just happens to be on hand. But if I didn't care about that, if I really only care about the start and end times, and I'm confident that, like the duration doesn't really matter, where I'm constructing those values, I will have already ensured that it meets the appropriate invariance, then maybe I would want to use the one on the top. So again, it's just kind of, I think it is useful to use the representation that for the specific code that you are writing happens to be the most useful. It's not really about trying to like capture every invariance about your data in the types. It's just the ones that allow you to avoid writing panic.
I was just going to ask about your opinion on dependently typed languages, like address. Do you think that's the way forward, or is it more complication than we need, or what do you think?
I think I know enough to say I do not know. I have used dynamically typed languages. Haskell supports some limited forms of dynamic typing. TypeScript even supports some limited forms of dynamic typing. Or not dynamic typing, dependent typing, sorry. And I think that they are useful in some situations maybe not worth it. I think it's always going to be a matter of opinion how much something like that is worthwhile, especially because different domains require different degrees of confidence. Like I work on a code base where we do care a lot about code working. Like the cost of failure is relatively high. In some other domains, it's even higher. And so I think as with sort of all engineering trade-offs like that, you can kind of dial it in depending on what you happen to be doing. I think when it comes to things like dependent types, one of the big challenges is code reuse. As your types get more and more precise, then it becomes harder and harder to reuse things because you need a specific fit-for-purpose model for each thing that makes it easy in your specific use case. So because so much of engineering kind of depends on the network effects of library supports and things like that, I'm not sure if it will ever sort of take off in the mainstream, but maybe it will. I don't know. I don't think I know how software engineering is going to evolve.
Okay.
Excuse me? Oh, okay. So, thank you for the talk, but I think I did not quite understand the structure where you said that a non-empty list is either a T or and then a list of T. My question with this is that given that in most languages there is a specific interface that list is required to implement, how are you going to be certain that the non-empty list will also be a list and will also be accepted in the same places? Because maybe...
That was the most... Is that a Spanish accent? Because that how... that sent ripples down my spine. That was aura.
Maybe it's not very clear in the list example, but in the non-empty list example, but there are other cases where all subtypes must implement the same interface, no matter, despite their structure being different.
Yeah, I mean, I think, I think the question is, you know, in the case where you have a non-empty list, then, would you have to implement the list interface? And would that cause trouble? Like, would you be able to implement the list interface in this particular case? Because and I mean, if the answer is no, then of course it doesn't implement the list interface. It's not a list, like in that sense. If there's, you know, if you want to be able to implement a list where one of the methods is like remove all the elements, then of course like it would not be a list in that sense. So it really just kind of depends on what the interface is. But of course, like if the list interface in your language of choice just allows you to like get particular elements out of the list, then you could implement that.
The list interface. Arguably, you shouldn't have a list interface anyway. It's more like a traversable interface, right? And like an appendable interface, and an emptyable interface. And then it becomes pretty obvious that non-empty list is not emptyable, right? That makes more sense. A list interface is already having issues because then you're giving like, you know, classic inheritance issues where like you're saying this is a thing, like the animal is a dog, as opposed to the dog can bark and, I don't know, can respirate, you know? So that already kind of sticks out. Hold on, does this work? FN F6 to play? Nope.
Obviously, whether or not that's worthwhile, again, is a judgment call that you have to make. I certainly don't think that rigorously applying this in every single situation is necessary. There's absolutely cases in our code base where we have a just like this should never happen throw, but it's a trade-off.
So it's again, it's a trade-off between whether re-implementing the list interface for this particular type is maybe worth it or not.
Right.
Okay. Thank you.
Yeah.
Thank you very much.
I'm curious how you apply this philosophy towards error handling, because in on the one side in the Rust camp, you have the very explicit enum based, explicitly enumerating all of your different error types. Then in languages like say Python or JavaScript, you've got the try catch, just handle whatever comes your way. How do you decide when to apply this sort of constructive modeling philosophy to error handling?
Yeah, that's a good question. I mean, I think I think my answer to a lot of questions is, well, it depends. I think that
It would do.
to some extent, of course, it's
But like programmers like general code, right? Generic code. They like code that can be applied to different situations because it means you have to write less. So like it's almost like a cry for less boilerplate. Like I feel like the perfect language, if you're going to design one, it is the language that lets the person just write what they think they want, and it works. Or like better, like more robust. They write code in the way that they think this should apply to this. I see no reason why it shouldn't, and I don't want to have to waste my time telling the compiler how it is valid, when it should just be valid because it should be defined such in a way that the compiler can automatically infer that it's valid. Like that would be the perfect language, because then it means I don't need to like redundantly just add boilerplate to my code just to have it like work. He said error handling, right? Like you would think that a non-empty list should inherit from the list interface, right? But that's an interface error. Like you've defined your list, or you've set up your interface system badly. You should not have a list be defined in such a way that you can't have a non-empty list or an even list, right? Like if it is a list, it should be a list. I shouldn't have to bend over backwards to have a non-empty list fit a list. Like the list should just be more accepting. So then you think about, shit, okay, but then what actually is a list? Like, does a list have to be empty? No. So I can remove the empty, does a list have to support being emptied? Well, in theory, no. So let's remove that function, the empty function. Okay. Does it have to allow appending to it? Well, not really either. It can be a static list. So then let's remove that as well. Does it have to allow being removed from? Also no. Okay, let's remove that as well. And then we get to a point where it's like, well, what actually is a list then? Well, it's just a list. It is a without using the word list. It is a group of elements that are linked together in some way, such that they can be traversed. And so you're like, okay, then I guess a list then is really just something that's traversable. And then that's how you get to the traversable interface instead of the list interface. And then you can bring back the other things, again, appendable, removable from, emptyable, and add those back as separate components that you can then combine to create, I don't know, like the emptyable, appendable, removable list interface. But the point is, at that point, you've broken it down. Now that's just, in that particular example is less of a language thing and more of a how you set up your class hierarchy. But the language features should be also written in a way that setting up the system to have, that remove, to have that kind of interface setup and hierarchy should be the easiest path. I should not require lots of boilerplate. That's what I mean. The best way to do it should not require boilerplate. The way that makes sense to the brain. Because the reason, literally a large reason that we have so many bad programming practices aren't even necessarily because people just, I don't know, default towards bad ways of doing things, but because they are influenced by how easy the language makes it. If the language makes it easy for me to crash my program, you're going to see loads of code where people just crash their programs because they're too lazy to implement the better way. For example, in C++, right? Yes, we have standard unexpected. Yes, standard expected. Yes, we have standard optional. But to use these features, because we don't have the question mark operator to early return, it's a pain in the ass to write if not has value, return, otherwise assign this other variable. Like that's such a hassle that a lot of people just won't do it. And they'll use exceptions, or like they'll just say, fuck it, we'll just assert, and then like, hopefully we don't deal with that. We don't have to deal with that. And that just creates sloppier code. Because that's the path of least resistance. Humans are cognitive misers. You study any psychology course, one of the first things you'll hear, humans are cognitive misers. We don't want to do the thing that takes more effort. If we have a goal, and we can sidestep the annoying stuff by just ignoring it. Yes, it might create issues down the line, but ultimately, our goals are fairly... Like, not every programmer has the goal, I'm going to write perfect software that will never crash, Because, like, there is a motivation meter. And that motivation will go down the more boilerplate you have to write. Or people will turn to, like, AI tools to write AI code for them. That also is a problem because AI can write unreliable code in other ways, right? Well, so what you need is not a language that, I don't know, is, like, better built for AI tooling, or that is... I don't know, has like more protection features. The design of the actual syntax and how you use the language is also incredibly important. And that is why I don't like Zig. It's why I have issues with Rust. Rust does a lot of things right, but it also does a lot of things frustratingly, annoyingly bad. And it's why I don't particularly like using C++ either. And that's what I want to focus on with True. It's why I'm putting syntax first with True. Because the syntax is so important for having the language actually be used to its full potential. And if you have a good syntax, like, it just ages better, because people will like using it. Like, we love features, I love that C++ is still getting features, but I know deep down in my heart that a language can easily, well, maybe not easily, but a language can definitely come along and just replace C++ one day. That language might be Rust, but I think even Rust will be replaced by another language. Because no one, for some reason, or very few people, seem to want to address the ergonomic issue of using languages. You can design a perfect language that has all the perfect features, has all the perfect abstraction, tools, but like if they're not convenient to use, very few people are going to use them. So that's the issue. Another example, very simply, C++ has no package manager. What happens? People use less libraries. Like, they literally use less libraries. One reason that C++ is actually quite, interestingly enough, one reason why C++ code might be safer is because it's less prone to, is it called dependency injection? Or, to supply chain attacks. Because, like, a Rust project will have, like, I don't know, over, like, 300 different modules for some reason. Like, 300 different packages included, as I've experienced firsthand, whereas a C++ project, no one can be arsed to get 300 projects manually and, like, do that, unless they have some, like, external package manager. If you're just using, like, CMake with C++, you're probably only, like, including, like, 2 or 3 particularly big libraries. Maybe you have a few utility libraries installed to your system, but ultimately, like, those will even be vendored, because you can't be arsed to, like, keep track of that, like, have those update themselves and, like, crash potentially, because it's hard to roll back automatically. Like, it makes such a massive difference, like, genuinely a massive difference, and it's not really talked about enough, I feel. Or even the fact that we use CMake in C++ and not, like, some other build system. It just means, like, people are more likely to actually configure CMake the way they need to, whereas people might be more inclined to just build and not configure it because it's so convenient to use stuff. Yeah, I don't know, but like it's interesting, right? And programming, but it also applies to other things in general when it comes to design. Like, again, if it's convenient, people will do it even if it's bad. Littering, for instance, littering is convenient, right? If there's no inconvenience to littering, but it is horribly inconvenient to put your trash in a bin somewhere because maybe there aren't enough bins around, maybe they're overflowing, maybe the place where you live is already so, filthy anyway, that, like, that putting stuff in the bin will have an impact, then the person is going to just disregard their moral compass and just say, well, yeah, I mean, like, at this point, I don't care. Like, I'm lazy. Like, yes, I care about this issue, but I don't care about it enough that I'm gonna go out of my way to, like, inconvenience myself to that degree. So the litter. You know, like it's such a fundamental human thing, and it's not accounted for enough. It really isn't.
It's a matter of ecosystem idiom. The two are mostly equivalent, like they're mostly interchangeable with each other. I think the major difference is just...
Sorry, that's a really good blog post. Two blog posts. First of all, multicultural nations. Other one I wanted to do was why humans choose convenience over correctness. Applies to code, but also life in general.
that one of them is checked and the other one is not, right? Like one of them sort of says these are, you have to declare what the results are. Java, of course, even has checked exceptions, which kind of makes the parallels a little bit closer. Those turned out to be perhaps not very ergonomic to work with for a variety of reasons. They don't have ways to abstract over the exception list and things like that.
Notice how she said ergonomic?
But even so, in principle, they're not necessarily that different. So I think really the trade-off there is just, like, you can design a system in such a way where you're using try-catch all over the place, and that's just the way that you handle exceptions. I think that it's nice to have the structured exceptions. I think the way that we tend to do it is that we use exceptions for like fatal errors where maybe we just want to fail the whole request or like something horrible happens. You know, we're going to take out the whole process, but then if there's something that we are going to handle, then we're going to return that in some structured way so it makes it clear what the potential failure modes are. And that works well for us, but again, it's up to you.
Hi, I'm Paul. I have a sort of practical question about when you're interfacing with type systems. There's many different types of type systems, unfortunately, with different semantics, where you have like the borrow checker in Rust that is a semantic model around the, like the LLVM machine model, you know, in some sort of very reduced way. Is there a practice when you are taking people who might not have much experience with type systems into a code base and saying, this type is for this specific area? Is there some sort of like guiding like toolbook that you have around that?
I'm not entirely sure I understand the question. You're saying, like, could you give an example maybe?
So for instance, like if you are implementing a type in a type system that is trying to limit the range at which you are able to modify the implementation of that type in all the consuming locations that are taking that type and using the data within that. Is there like sort of a limit?
Yeah, what? I have 3 modes on my keyboard. That's weird. So like FN backspace is my full keyboard's lit. 1 just highlights my WASD and arrow keys. 2 highlights the left side of my keyboard, and 3 highlights just the typing keys. So like QWERTY and then some symbols, but not the numbers. No, also the numbers. Oh yeah. Then also arrow keys. What? No, what? That's so weird. Can I remap those? It doesn't say. And then there's also like speed options. I can make it faster or slower. Yeah, sorry, that just distracted me.
The range at which you are able to modify the implementation of that type in all the consuming locations that are taking that type and using the data within that. Is there like sort of a way in which it may
makes it obvious about how I could modify that type if you wrote it.
I think I still might not entirely understand are you saying, like, suppose that you have some type definition and it was designed with a particular intent, and it might not be clear to some subsequent programmer, like, who might modify the type that intent was there and what intent should be preserved. I mean, I certainly think that's a really great situation to write a comment. I think something that's sort of funny is for my entire career, I feel like I've definitely been the sort of person to in code reviews say, oh, can we add a comment about this? And now with LLMs, I spend almost all of my code reviews saying, please delete every single comment. But I think my opinion has always been that, like, why comments are really useful, and saying, like, something that is not possible to infer just from reading the code, something like that, like, this type is intended to preserve this invariant. That's really, really useful, rather than just saying, like, this user type represents users. Maybe less useful.
Yeah.
All right, I'm going to snag the last question here, and then we'll go to lunch. So you sort of poured some cold water on, like, type system innovations that people are excited about, like TypeScript, for example. Which also reminds me to call out grugbrain.dev. We've got Carson Gross, the author of that here, and in there, there's a line, something like, type system good, just not too much, you know, so I like that. But I'm curious, are there any innovations in type systems that you are excited about that you do think will be more fruitful?
That's a really good question. I think that my answers are probably going to be, in some ways, idiosyncratic to me and the way that I write code. Like, Haskell has some features that I really, really like. There's the perhaps unhelpfully named generalized algebraic data types, which doesn't really describe anything about what it does. But it sort of extends this type of data modeling where you can sort of restrict, like, you can have an enum where certain cases are restricted based on some statically tracked information. In all my time writing Haskell,
that should be a D, by the way. Lexer. Specification of each data's constructor's return value. Alexa, Alexa char, Alexa float, Alexa double, Alexa int, Alexa integer. Huh? So it's like a constructor. Okay.
Haskell and using all the different fancy type system features, that was the one that I found the most directly useful, which I was a little surprised by. Like, it has this really scary name. Unfortunately, it's a little bit hard to explain without some code examples. I think that that is fruitful in Haskell because of the way that it sort of integrates with all the other features that Haskell has. So I don't know that I could easily say, well, you know, it's going to be the future of statically typed programming. I definitely also think that structural typing is something that has not been seen that much outside of, like, gradually typed languages. But I would really love to see more languages that are designed to be statically typed from the ground up that still utilize a lot of structural typing, because I think it makes doing a lot of these things just a lot more convenient. It cuts down on the boilerplate, and when things are easier, people tend to use them. So
when things are easier, people tend to use them. There's like a much bigger discussion that's hiding within this talk, I feel.
It's wonderful. Thank you.
But yeah, that was cool. Thank you, software should work. Is it just one channel, or like will they continue uploading after they finish? because they only have so many talks. Who knows? Oh, this just got uploaded. Reliability lessons from SQLite. I'm subscribed? Since when? Okay, I use SQLite, so honestly I don't really care too much. But okay. So, interesting. I know what I want to write about next. And give me some good thinking for true. And what I want true to be. Because I'm sick of settling for less, you know? Anyway, I'm gonna not read these now, but I'll add them to my reading list that never gets read. Nah, I'll read it at some point. But how do I choose? Yeah, Obsidian. I was going through it a night earlier, I think, and I came across, I don't know what it was, but like, yeah, I have a lot of things to read here, and I will, I promise. Maybe. Yeah, and I've got washing to hang up, and probably I'm gonna eat dinner as well, because why the fuck not? But cool video, interesting talk. Might probably I don't know. I don't know if it'll change how I program. It definitely change how I program when I enter the job market, because then I'll be using languages that I may not like, and then having like workarounds to annoying issues. You know, that's the things that she defined or talked about are quite useful tools to like have nice static typing in a language that might not have other features to make it nicer. So that's cool. Otherwise, yeah, I don't know. Just give me more thoughts about true. Yeah, which is always good as well. So there you go. 2 hour and 15 minutes. Yeah. Subscribe for more programming language design related content.